All right, in this video, we're going to learn how to solve by square roots. This is Module 10, Lesson 3 for my students. Okay, so when we're trying to solve a quadratic equation, there are times that it will be given to us where we already have a squared term. So here we have x minus 2 in parentheses squared. Then we have plus 1 is equal to 10. So this is still a quadratic because I have this exponent of 2. So the first thing we need to do to solve using square roots is to isolate the term that is squared. So in this case, this parentheses that is squared. So we have to get this all alone. And so we're going to have to move that positive 1 to the other side of the equal sign. So we're going to subtract 1 from both sides. Once we subtract 1, then we have x minus 2 squared is equal to 9. Now our second step is to take the square root of both sides. So we're going to take the square root of x minus 2 squared, and we're going to take the square root of 9. Now the reason why we're taking the square root is because we want to get rid of this exponent of 2. And the square root of 9, most students know, is 3. But we have to remember that it's not just 3, it's also negative 3, because the square root of any number can either be positive or negative, because negative 3 times negative 3 would still equal 9. So because of this, we need to make sure that we account for both the positive and the negative root. So now we have x minus 2 is equal to plus or minus 3. This is how you're going to see it written mathematically most of the time. And so now we have to solve for x twice, because we have to solve for x, or we have to when it's equal to 3. And we have to solve for x minus 2 when it's potentially equal to negative 3. So we're still going to have two possible answers for x. So x minus 2 is equal to positive 3, and x minus 2 is equal to negative 3. That accounted for both the positive and negative solution, or positive and negative root of the square root of 9. So now we're going to solve for x by using inverse operations and adding 2 to both sides, so x is equal to 5. Or we could add 2 to both sides, and x could possibly equal negative 1. So these are the two solutions, two roots or zeros of the quadratic function. Or this is actually where this quadratic function would cross the x-axis, is at 5 and negative 1. Now, there will be times where we would have to simplify the radical. Now, if we had a non-perfect square here, we would have to simplify the radical in order to arrive at our final answer. So we'll see more examples of that on the next page. So because we are dealing with radicals or roots, we do need to remember how to simplify a root. So this is just a quick review of what we did in our Module 7 with exponents and radicals. So you can use this to help jog your memory as far as how to simplify a radical. All right, so again, our first step in example A is going to be to isolate the squared term. So we have x squared, so we need to get rid of that positive 2. So we're going to subtract 2 from both sides. Once we have x squared is equal to 49, we're going to take the square root of both sides so we can get rid of this exponent of 2. Well, the square root of 49 is a positive or negative 7. Again, we have a positive solution and a negative solution. And because we don't have any other terms to worry about, we're done. Those are our two answers. All right, then we have x squared plus 2. So very similar to example A, but now you're going to see what happens when we don't have a perfect square. So now we have x squared is equal to 24. Well, we're going to take the square root of both sides, just like we did before. However, the square root of 24 is not a perfect square. So x is equal to plus or minus the square root of 24. If the problem requires you to simplify, then we have to simplify that radical. So the square root of 24, the factors of 24, are the square root of 6 and the square root of 4. So what I did was I used this largest perfect square method in order to factor or simplify my radical. Well, the square root of 4 is equal to 2. I cannot simplify the square root of 6 any further. So I'm going to end up with 2 square roots of 6. So my final answer is x plus 2 square roots of 6 and x equals negative 2 square roots of 6. Sorry, so I said x equals plus a positive 2 square roots of 6 and x equals a negative 2 square roots of 6. All right, here we have a squared term that has a coefficient. So we're not going to distribute the coefficient. We're not going to subtract the coefficient, but we're actually going to divide by that coefficient so that it's moved to the other side of the equal sign. So when we divide both sides by 2, we get x plus 1 squared is equal to 121, because 242 divided by 2 is 121. We're going to take the square root of both sides, and when we do that, it's going to get rid of our exponent. And we have x plus 1 is equal to plus or minus 11, because the square root of 121 is 11. Now we have to account for both the positive solution and the negative solution. So we're going to take this x plus 1 and set it equal to a positive 11 and solve for x by subtracting 1 from both sides, and we get x is equal to 10. And then we're going to do x plus 1 is equal to negative 11, subtract 1 from both sides, and we get x is equal to a negative 12. I don't know what happened to that last step, but it is x is equal to negative 12. Finally, we have x minus 7 squared is equal to 40. So our squared term is already isolated, so our first step is done for us. Our second step is going to be to take the square root of x minus 7 squared and take the square root of 40. Now again, 40 is not a perfect square, so x minus 7 equals plus or minus the square root of 40. So I would have to add 7 to both sides, and there I have x is equal to plus or minus the square root of 40. However, now I need to simplify that radical. So the square root of 40 can be broken into the factors 4 and 10. And I remember from previously, the square root of 4 is equal to 2. And so I can't simplify the square root of 10, so I have 2 square roots of 10. Okay, so x is equal to 7 plus or minus 2 square roots of 10, or I would write it separately as 7 plus 2 square roots of 10, or x could equal x minus 2 square roots of 10. Be careful and keep track where that plus and minus are located. All right, that is it for your notes for Module 10, Lesson 3, Solving by Square Roots. You do have a couple of practice problems, more than a couple, because the more you practice, the better you're going to get. So complete these practice problems, complete them in Canvas, and you'll be ready to go for the quiz.